All right, so the parent function of an absolute value function is y is equal to the absolute George value of x. Okay? This is what your function looks like when it's graphed. Okay? Looks like a V. What does the graph of an absolute value function look like? A V. The graph of an absolute value function looks like a V. If I see a V, I think the function is probably an
absolute value.
Very good. I said that 3 times, people. And there will be 2 people in this class on their test with a calculator in their hand will draw a line on a graph for an absolute value. I do not know what to do with you, okay, except to mark your problem wrong. I don't feel sorry for you. So range starts, look, from the bottom, the range starts at 0. Is the 0 included or excluded? Included. The absolute value of 0 is 0. Okay? So my range is from 0 to positive infinity. Now, everything else below this graph, we are going to write later on. We're not going to write it now. But it's all the kind of little secrets that we are going to discover as I graph absolute value functions. Everybody got it? Okay, so I need a favor. I need one of those. Does somebody in here have one of those fancy schmancy calculators that's like electric or whatever? Yes? That lights up. Lights up.
No, I
A
don't
backlit one. Harrison, can I borrow it, please?
Rich boy,
Because
let's
they show
go.
up a lot better on the screen than the other one does. So, oh no.
Oh no.
It's an Inspire. I know.
There's about a minute.
This is stupid.
So it's gonna always pull it back, the value now? If I do it? So just have a light. Here, let me go, I'm gonna go find it, wait, I know, I'm gonna go get one next door. I'm gonna go get one.
We're useless.
Thomas Davis.
Useless. Not good enough.
Palindrome. It
One
has
window.
graphs. I managed to make a palindrome. So
This is easy.
it reads the same forwards as it does backwards. Never mind, it doesn't. If you look, the first one did.
It uses very smart backwards.
How many bear claws do you
I
have?
think you predict from the variables.
One. The only reason I have one, and I actually have one bear claw, is because it was the biggest bear.
Ah, okay, so all the other bears weren't good enough. You just
No, they
threw
weren't.
them in the volcano.
Yeah, volcano.
Volcano, he's in Alaska.
There's a volcano.
He swam to the nearest volcano to explode to their body.
5, 4, 8, 9. Oh, it's just a. But it's the same.
It's the same forward and backwards.
Alright, look,
We
one.
ran across there. So is it true
When they
that
can't pay for skis, they just tie a rope on the end.
so is it true that to dispose of the inadequate bears that you killed so easily, you ran across the ocean and threw them in a volcano?
Oh, yeah. Yeah.
Right.
Of course, obviously. Do you all
Yeah,
not
you
know
put
that?
the bears on the way over the ocean, right?
Yeah.
Yeah.
The bears that were on the ocean, I killed those ones too.
Yeah, instantly. You looked at them and they
Okay,
exploded.
so here we go, guys. All right, so here's what we're gonna do.
was on the phone.
Are you
Thanks
ready?
for letting us know.
I'm gonna zoom in.
Oh.
Fancy.
Okay.
Too close to that.
This is Miss Stewart's phone.
That's
she
a
let me
phone.
borrow.
That is a
Okay.
phone.
Yeah. So I'll make it focus on it a little bit better.
I'm about to download that on
I know, it looked just like a calculator. When she said that, I was like, what? And then I was like, oh my gosh,
Would you have to pay for this?
weird looking. So, all right, you can't have an iPhone and do it. It won't let you do it on an iPhone.
What?
Okay, so I'm gonna go y equals, okay? So where is absolute value?
Y equals absolute value.
Where is absolute value on
That would be,
Oh.
you could do
Math.
math catalog.
Okay, I'm gonna go alpha and L2. Y'all do whatever y'all like. Oh, she doesn't have any alpha buttons. Dang it. The phone keeps buzzing. Yeah, she does. Okay, so absolute value of X. All right? So now I'm gonna graph it. Whenever I graph something, I always like to press the zoom button. All right? Now, I'm gonna just do a zoom standard, a 6. Okay? Which is a 10 by 10. So here's my graph right here.
No, it's a B.
It is a B, because it's an absolute value, right? All right, so here's my question. What if I go back to y equals, and I go down, I go alpha, alpha, 2. This thing does not like me. And I go x minus 3. So, first of all, what do you know the graph will be, people?
A B.
A B, okay? A B. I promise you it will not be a straight line, all right? So it will be a B. What do you think that minus 3 is going to do, that original parent function?
It's gonna
We're
offset
going to
it.
drop it down 3. Anybody else care to guess?
It'll offset.
Gonna drop it down.
Offset it what? Where?
It's a view.
Oh, it's
my
gonna
God.
where the 0 is? It's going back out.
It's going to go down 3, okay? I like down 3. Offset, I don't know what you're talking about.
It moves it from the original position.
Which way? You got to give me direction and number.
I thought math was
Down 3.
Down 3. What do you say? Up 3? Okay, Gunner says up 3. Anybody else? All right, so here we go. Graph.
Yeah, it's absolutely.
Oh, what? Which way did it go, guys?
Right.
Right 3.
Oh, wait.
Weird, right, Caleb? Okay, so it's the absolute value of x minus 3, and it went to the right 3. Why do you think it did that?
Oh.
It's an absolute value.
Oh, okay, so
Got
it's
it.
an absolute
That
value.
makes so much sense.
Absolute value is always positive, so it took that minus 3 and make it a plus 3. Okay, so if that is true, okay, then if I take this equation and I put a plus sign right here, it should look exactly the same, right?
No, it should go the other side.
It'll be.
Okay, so, George,
Smarty.
okay, so let me tell you something. People, is that the same equation?
No.
Then it will not be in the same place. Do you see how that doesn't make sense? So, let's go with what George said. George said it's going on the other side, okay?
About to see.
So, here we
She gave you
go.
high five,
Look
so
and
be
see.
I killed
confident.
7 whales.
Be com-
That is daggone right.
Kill one more, you can join the club.
Can't you
Hey,
make that go faster?
guys, pay attention.
I'm a genius.
Look at there. It went 3 to the left. So tell me what your hypothesis is. What do you think is going on?
If you subtract from x left in the absolute value, it goes to the right. If you add it, it goes to the left.
Oh, here's what Gunner said. Gunner said, if you're in there inside the absolute value, if you subtract, it goes to the right, and if you add, it goes to the left. Okay, so let's test it. If that's true, then I'm going to go down here, and I'm going to go minus 5. Which way should this go?
Right.
And how many?
5.
Okay, let's see.
Sorry if I am wrong.
Turn this upside
What?
down.
Oh, it goes to the one. Okay. So yeah.
Math.
Okay, so there it is. Now, if I go back, so that one looks pretty good, right?
Mhm.
So if I go back,
Big fingers.
and I go plus 2, that should go
2 to the left.
2 to the left.
Pretty sure.
That's my parent function.
It has to go, we already did this before. Well, it's-
Did it do it?
Yeah.
Okay, so here's the deal, guys. Listen to me. This is this way with every equation that you ever do. If it's with an x, it is an x. And it moves left and right. Does that make sense? Which way does the x-axis go?
Left to right.
Left and right. But it's opposite of what you think. So the minus goes to the right and the plus goes to the left. Okay? But y'all listen to me. Here's the coolest part. X's are weird. They're always weird. The x's always do the opposite of what you think. okay? So if it's with an X, it is an X. Remember the other day when we said X's go with X's and Y's go with Y's, okay? So if it's with an X, now y'all listen to me, are you supposed to be writing this down?
No.
No, because I told you I have it all for you. I'll let you take a picture of it or whatever. Right now, I don't want you punching stuff in your calculator. I just want you listening to me, okay? Listening to me and answering my questions. All right, so everybody got it. If it's with an X, it is an X. And it moves it left or right, opposite of what you think. Y'all look, I'm gonna show you something. Now this is a pre-cal problem.
Oh.
It's a trig function.
Yeah.
Look at that, minus pi over 3.
Yeah.
Look at that shift to the right, pi over 3.
Yeah.
It doesn't matter what it is. It can be a sine function. It can be, we don't want this thing to go out because it's a fingerprint thing. All right, so let's try something else. What if instead of
You're there.
down here, what if I put something out here like a +3?
It'll move it up or down.
Did I move it up?
Yes, because it's not with an X.
Oh, George, you're scaring me because I'm like thinking we're thinking alike.
No. You probably actually that's very cool, maybe.
All right, so here's my parent function. Oh, did it go up 3? Yes, it did. Okay, so if your hypothesis is correct, if I go down here to this equation and I go -3, where should it go?
Negative.
It should go down 3.
Oh God. I got my wand and everything.
Okay, so there it is. So guys, listen to me. Here's the deal. If it's with an X, it is an X, and it moves it left or right, opposite of what you think. Y'all, if it's not with an X, notice I didn't say it's with a Y because we solved for Y, so Y's by himself, okay? But if it's not with an X, it must be a Y. Y's move where?
Up and down.
Up and down, just like the Y-axis. How do they move?
Wait, what?
Up
What's your X?
Like,
How do they move?
if it's positive, you go up.
Yeah, just like you think, right? A plus goes up and a minus goes down, just like you think. X's are opposite, but Y's are the same. Okay, so let's go back here. Let's do something else. Let's go down here. I'm gonna clear this guy out. What do you think is gonna happen if I stick a negative sign in front of that absolute value?
It'll flip it. Yeah.
It'll flip it. Okay, so let's see if it does.
So easily.
So there's my parent function. Oh.
Now it's making an actual X.
So there's my other function. It did flip it. I don't really like the word flip, okay? So I'm going to use the word reflect. It reflected. Now listen to me. This equation right here, is this negative on the X or the Y? Yeah. He's really on the Y. If he were on the X, where would he have to be? Inside there on that X, okay? So he's on the Y. So if you put a negative, like on a Y, that reflects it over the X-axis. Remember that a quadratic, a parabola, was positive X squared opened up and a negative X squared opened down. This is the same thing, guys. This is the same thing, okay? It's that way for everything. So what happens if I do this? Look at this parent function. What is the slope of that curve? 1. There's a 1 in front of that. It's understood. I don't have to write it. Okay? What if I change that to like a 3? I'm going to do something for you. You see this word format right there? I'm going to go second and format. And I'm going to turn the grid dot on.
So wait, that just means it's a steeper V?
Yeah, it's a steeper V. So instead of going up 1 and to the right 1 and the left 1, he's going to go up 3 and to the right 1 and the left 1. Okay? So I'm going to graph him. What? I thought I turned that
I
on.
didn't click it.
Oh, I didn't click it. Sorry. I'll
Just
go
do
back
second
and click
click.
it. I
Oh
will.
wait, you did.
No, I didn't.
Yeah, you did. It's steeper.
She was talking about the dots.
Oh.
Math comes so
Second and format. I'm going to turn the grid dot on. So now watch what happens when I graph.
Oh boy, I don't know.
Oh, okay, for a second there, I thought that was the absolute value.
No.
I was like, wait a minute.
Okay, so notice in the parent function, it's really hard to see, okay? I'll see if I can push it up here a little bit. Notice on the parent function, you can go up one and over one, to the right one, and up one and to the left one, and you're on that blue graph. But this red graph, he had that 3 in front of him, so he goes up, 1, 2, 3, to the right one, to the left one. Did y'all see that? It's really hard to see. Okay, I'm sorry. I thought somebody in here would have one of those calculators. I don't have one. Okay?
I'm sorry.
All day somebody's
I
had one.
apologize.
It's okay. Garrison had one, but it was a newfangled one, and I really don't know how to work that one.
Angle?
Okay, yeah.
What does that mean?
That means that's I don't know, when I don't know how to work. So here we go. So, now look, I want to show you all the stuff that you've learned. Okay? So let's go back to y equals. Now this 3, does that 3 have to do with an x or a y?
Oh, wait, no.
Yeah. If it had to do with an x, where would he be? Inside with an x. Okay? Y'all listen to me. If it's with an x, it is with an x. It's either in parentheses with an x, it's under a square root symbol with an x, it's in an absolute value sign. It has to be in there. It can't just be like right beside it. Okay? So this is called a vertical because it has to deal with the y-axis. Okay? And it's called a vertical stretch. The y's are just like you think. If you tripled my height, would that be a vertical stretch or a vertical compression? Stretch. Okay? What's going to happen if you stretch somebody? Are they going to get fatter or skinnier? Skinnier. What happened to that graph? It got skinnier, didn't it? Okay? It's got skinnier. All right, so what's going to happen if I go here and instead of a 3, I put a really small number? I'm not talking about a negative. I'm talking about like a fourth or a decimal. Okay? I'm going to do a fourth, but I'm going to use the decimal equivalent of it. I'm going to go point, and then I'm going to go second and insert 25. So 0.25 times the absolute value of x. Now, is this going to be a vertical stretch or a vertical compression?
Compression.
Compression. That number is smaller than 1. Okay? So this v, should it be fatter or skinnier than the parent function?
Fatter, wider.
Here's my parent function. Look at that dude. Okay? So, look at him. He is, look, here's the parent function, up 1 and to the right 1, up 1 and to the left 1. Now listen to me. Here's what I'm going to require on your graphs. 3 points to graph an absolute value. One is the vertex, that point, the V point, and the other 2 will be gotten from the slope. Like this one would be this point, and then I go up 1 and to the right 1 and to the left 1. On this guy, I got the 0, 0, okay? And then I'm going to go up 1 and over 4. It's a fourth, people. 1, 2, 3, 4. There he is. And then I'm going to go left 4. 1, 2, 3, 4. There he is. So those are going to be my 3 points. Does everybody understand?
Yep.
So should I be able to graph any equation without a calculator?
Yeah.
So if I give you a calculator, you for sure should be able to graph it. Do you agree with that? Will it be a line?
No.
Y'all, if it's an absolute value equation, it will not be a line. Okay? So, I'm going to stick one up here, and then I want you, quietly to yourself, to figure out where this thing is.
This big.
It's in like.
Okay, but y'all aren't supposed to be using your calculators.
Oh.
You're supposed to be using your brain.
Oh, I got it.
Okay? You're supposed to be using your brain.
Oh,
This is-
man.
Good.
It's on negative 4. See, it's on negative.
Well, which one's it comes over?
No.
Oh wait, no, it's supposed to be on this side.
No.
Okay, so watch this. First of all, what does this negative right here in front do to my graph?
Makes it go like,
Yeah, makes it up and down instead of up. Are you with me?
And then it goes over.
What does the 2 do to it?
makes it,
Yeah, that's its slope. So instead of, to get my point from my V, I'm gonna go down 2 and to the right one and to the left one. Are you with me? What does this plus 3 do to it?
moves it over to the left. Three
Left
times.
3. He's with an X. He's weird. He's doing the opposite of what you think. So I went left 3. What does this minus 4 do?
Goes down.
Down 4. So I'm gonna go left 3, down 4. That's my point. Okay? And then,
You got it.
arr,
Just tap the like up or down.
Oh my god.
so left 3, 1, 2, 3, down 4, 1, 2, 3, 4. My slope should be negative 2. Down 2 and to the right one and to the left one. Are you with me?
Sure.
Okay, so now I'm gonna test and see how good you really are. Because this time, I'm gonna graph one and you're gonna write the equation for it.
Okay.
That's the most difficult, okay?
My brain What was that?
It's from grizzly bear.
Ate too many.
It's been a while, actually. It's been a while.
No, I was gonna do
Tell us how
actually
you
eat.
killed that big old black bear.
Like,
Huh?
did you actually eat black bears and all that stuff?
Not really, they don't taste.
He's snapping bears.
So not really means you did, but you didn't really enjoy it.
Yeah,
What do you eat up there? Salmon?
salmon and deer and moose.
That
Pretty
sounds
much it.
great. So
It
that's
is.
all you eat.
Pretty much meat wise and
wonderful.
stuff.
So isn't it illegal to kill a person in Alaska? Like, if they
I
go
just
to your
don't
house.
understand.
Stop. Hush.
I'll understand.
Okay,
No.
so here we go, guys.
Alaska's part
Right
of
now,
America.
shh, go. Write an equation on your paper. Write the equation to this graph on your paper.
Is that 4 to left or 5?
Now, I will say this, when you're doing this on this little bitty graph up here, it's hard to count. Do you agree?
Yeah.
If you're doing it on a piece of paper that's gridded off on your test, will it be that difficult? No, it won't.
Okay.
That number's wrong.
I can't see
Is
that.
that right?
I can't.
Hey guys, look at me. Look at this graph right here. Does this graph look like the same exact slope that the parent function had?
Is it?
Oh.
What? It's not 1. Y'all, it's not 1. People, it
Is it
can't be 2.
Huh?
Yeah,
Thought so, okay.
yeah.
Wait, what?
Like, look, y'all, here, let me put the parent function, let me put the parent function up there and let you compare it and tell if it's wider
I
or
just can't
narrower.
see the dots.
I actually see
Okay,
them
so
right,
here it
but-
is.
Which this is right.
To get, here's the point, do you agree?
Yeah.
So I go up 1 and over,
3,
how many?
3,
2.
2.
Up 1 and over 2, up 1 and over 2,
Okay, I thought it looked just like
okay? No,
Yeah.
so it's a half, all right? Why does this thing keep getting darker and darker? Dang it, I shouldn't have waited till 6:30.
If you do like second, then the up arrow or down arrow, if you make it brighter
Oh, thank you, yeah, you're right. Oh,
or just touch it. The screen says no.
okay, so, here it's gonna be, are you ready? It's gonna be y is equal to, first of all, is it opening up or down?
Open it.
So my number in front should be
Positive.
positive. My slope is up 1 and over 2, 1/2.
Yep.
Absolute value. How many did it move to the left? 4. 1, 2, 3,
Plus
So
4.
that's X what?
Plus 4.
Plus 4, very good.
Okay,
Minus
I thought it was
How many
five,
did it
but
go
you said
down?
1.
1,
So minus.
minus 1.
Because you have a
Okay.
big-
Yeah, let's go, I got it. First time.
All right, so here's what I want you to write down. I'm gonna have to refocus this thing because I'm gonna pull it back off of here. These are the rules. Before you, I'm okay with you snapping a picture or something and then putting it in your notebook later, okay? But before you snap a picture, I want you to let me read through them and talk about them, okay? Otherwise, I'm gonna be in your way. So, I just gotta find them back here. Here it is. Okay, so this is the rest of the page. We wrote this down at the first of class. Now let's look over this. If it is with an X, it is an X. And it moves left or right, opposite what you think. Do you agree with that? Okay, the next bullet. If it's not with an X, it is a Y.
Yeah.
We can't say it's with a Y because the Y is going to be by itself because you're graphing it. And it moves up or down, like the y-axis, just like you think. Positives go up, negatives go down. You with me? If you have a number in front of the function and it's multiplied by it, this is what I'm talking about, people. Remember how we put these numbers out front right here? Okay? So like if I put a 3 right there, that was a vertical stretch or compression? Stretch. If I put a 1/2 right there, that was a vertical compression. Okay, that's what it's going to say. The number in front of a function and multiplied by it is a y. So it's a vertical. If it were in there with the x, it would be a horizontal, like the x-axis. Okay? And that would be the opposite of what you think. So it's a vertical stretch if that number is greater than 1. I'm not talking about the number sign, so I'll put an absolute value on it. It's a vertical compression. We used to call them shrinks, but now you see the word compression more in our math books. If the absolute value of that number is between 0 and 1. In other words, it's those little fractions, little decimals. If, we're not really going to talk about this, but we will after this test in the next section. If the number is in front of and multiplied by an x, he's with a weirdo. They do the opposite of what you think. So a horizontal, because it's with an x, it's horizontal. A horizontal stretch is going to be the smaller one, and a horizontal compression is going to be the bigger number. Okay? It's just always backwards. All right, so I'm going to leave this up here, and you take a picture or write it down or whatever, and then I'm going to stop the video. Okay?
Do you want me to bring the person's phone?
Yes, it's his students next door. Thank you.
How flat?